So we are live. So hello everyone, welcome to the Kubernetes Community Days session 2. We are having an extended version with Moaz, who is a software engineer at Grafana Labs. He will be hosting a session on continuously delivering hundreds of thousands of Kubernetes deployment and Grafana Cloud. So Moaz, will you like to introduce yourself?
Yeah, let me just share my screen.
Okay, perfect.
Okay, if everything's working, you should now be able to see my screen. Oh yeah, there we go. It works perfectly. Yeah, so this is continuously delivering hundreds of thousands of Kubernetes deployments at Grafana Cloud. Definitely a big title. I am Moaz. I'm a software engineer at Grafana Labs. I've been there for a couple of years now. I'm originally from Lahore. I grew up in Lahore, and I went to university in NUST in Islamabad, and have been living in Berlin for the last like 6-7 years, and I've worked for like another company here as well. Yeah. So at Grafana Cloud, we run hundreds of thousands of Grafana instances. And so this is not nearly, like this picture doesn't nearly show like the amount of scale, but I just wanted to kind of convey like how many instances that is. Like that's just a huge number. And all of these are Kubernetes deployments. So they're not really any different from any other Kubernetes deployment. And when a person kind of like signs up to get their Grafana instance, they get like your standard like Grafana instance with some extra features. And one of the things you get also is our provision plugins. So these are like plugins that are installed by default on these Grafana instances. We've got like a dozen of those. So when you sign up for the account, like it may look slightly different from just your standard open source Grafana. And all these Grafana instances are regularly updated. So all the Grafana versions are regularly updated, and all of the provision plugins that are available on these instances are regularly updated as well. And today, I want to talk about the open source technologies that we kind of have stitched together to make this system happen, to make like Grafana as a service happen for Grafana Cloud. So if you when you deploy, a Kubernetes deployment at work, the simple flow is, you take a Kubernetes manifest. This can be a YAML file or a JSON file, and etc. And you just use like kubectl apply and apply that to Kubernetes. And at Grafana Cloud, of course, we want to accept, like users want to, like make the request for a new Grafana instance with the web, so they go to grafana.com and just like and create a Grafana instance from there. So to do that, we have an API, a Node.js API, where you can like accept these requests. And Node.js is the first like technology that I will talk about just briefly. We've been using Node.js from pretty much, I think, the start of Grafana Cloud. And not as many new services as many Grafana Cloud services are written in Node anymore, but we still have like a ton of front end stuff and just like a ton of other stuff still in Node.js. And actually, if you go to grafana.com today and create a new Grafana instance, you will be using Node.js. So another difference from when you might be deploying something to Kubernetes yourself is that we don't actually want users to have to figure out what exactly should the Kubernetes manifest of their Grafana instance should look like, of course. So what they do is that like they just like make a random HTTP request. They just tell us like what region they would like their Grafana instance to be in. We've got multiple regions now, and we kind of like do the rest. And one of the steps that gets added into the process, if you see the difference from this like last image, is rendering a manifest. So we've got to take this like user request, which kind of just tells you, oh, I want like a Grafana instance, and I want it in this region. And it gets kind of like translated into a Kubernetes manifest, and that's what I'm calling rendering a Kubernetes manifest. So normally you would, another thing you would do when you're doing this yourself is that you would just like use Git to store this manifest before you apply it to Kubernetes. This is, like for version control, if you make any changes, to these manifests, like they can be, you get a like nice version history with Git. But you can't really do that when you have hundreds of thousands of instances. Like that's like too many files for to maintain Git. And of course, like operations on Git also like get slower, like the more files you have. So that might not be feasible. So what we need here is a database. Databases can handle, of course, like hundreds of thousands of rows, like and many more. Like some databases can handle even more. And so the database that we use like often for this at Grafana Labs is MySQL. So another open source technology, like it's been around forever. Grafana open source itself uses like MySQL. And I think like that was also like another reason that it kind of got some adoption at Grafana Labs. Another nice thing about MySQL is that it's available from all of the cloud vendors out there. Pretty much, they have some version of like MySQL as a service, so you can also use that to kind of like get a MySQL cluster. So the steps are pretty much the same. Not so much has changed except the technologies that are being used. A user makes a request, like there's a Node.js API that kind of receives this request, and we render their manifest and store it in MySQL, and then apply it to Kubernetes. Another thing that's different though, like as we're running it in Grafana Cloud, is that we don't really use the command line version of kubectl. And in fact, like to render these manifests, there is a Go app that kind of like handles like this layer of the system. And Go's like been many of the core technologies that came out of Grafana Labs are actually written in Go. So it's becoming more and more popular within Grafana Labs. And one of the things that I'm impressed by with Go is like the simplicity with which you can like learn the language. It's quite easy to learn. It uses like constructs that all of us just like studied in university, and there's also that it's got like good concurrency support, which like keeps things kind of very manageable when like building kind of big systems like this. So you might have started to notice that there's like the picture is starting to get busy. So let's simplify it. We'll just like simplify it to this. So we get a user request for a Grafana instance. We render this into a MySQL database, and we Kubernetes apply the manifest itself, and then we've got a Kubernetes instance, a Kubernetes deployment, and a Grafana instance. So another step that I talked about briefly before is that we don't really use the command line version of kubectl. It wouldn't really work, and because we would want to make like too many parallel requests for it, and you would just get like a shell process like each time you would do this. I imagine that's how it would be. But luckily, Kubernetes gives you a way to use your favorite programming language to make API calls to Kubernetes. So instead of using the command line version of kubectl, we use the Go the official Go client for the Kubernetes API. This is called Client Go. It's like on GitHub. You can see it. It's like a pretty powerful thing. More and more, like our applications at Grafana Labs, they use Client Go. It's got like support for the complete Kubernetes API. Every time there's a new Kubernetes version, a new Kubernetes API version, a new version of Client Go is released with support for it. So that's pretty nice. It's also got like some powerful support for watching events, which is like an important thing in Kubernetes, is like watching changes on Kubernetes deployment. It comes in handy that Client Go has support for it. It also supports like caching these events. So not only, if you're interested in a particular like Kubernetes deployment, not only can you make an API request like every few minutes to see, like if the deployment has changed, you can also like receive events, but also it's got like data structures that like make sure that you can just use, like your local cache, which is like updated from time to time. As like the resources that you are interested in become updated. Ask me more questions about this later if you're interested. But that's as much as I'll probably say about this now. So one thing that we kind of like didn't really talk about is versions. It's what version, when will the users get for Grafana? I talked about all these like default plugins that we install on a Grafana instance. Like, what about those? We've got like a dozen of those by now. So what version should the users get when they sign up for a new Grafana instance? And you'd be right. What we do is that we've got a mapping of the stable Grafana version. We've got an idea of like what is the stable version of Grafana and what are the latest provision plugins version that are supported by this Grafana version. So those we store in Git, and when a new request comes in, this like Go app like fetches whatever is the like latest version of the stable version, of Grafana, and uses that and the latest version of the provision plugins, and uses that to create a Grafana instance. Sorry for my fumbling. So there's a few steps now. So I just like numbered them for us to kind of be able to follow it. Step 1 is a user sends a request for their Grafana instance. Step 2, we figure out like what is the stable Grafana version right now, and what are the latest provision plugin versions that are supported by this Grafana version. Step 3, I actually like missed a step here. So step 3 is that we render the manifests. We figure out like what does the Kubernetes manifest for this request should actually look like. We store some information in the database, and then we kubectl apply, or like through like Client Go, like make like Go API requests to Kubernetes to actually like create this instance. But as you know, like the stable, like the version of Grafana is always changing. There's a new version, I think, every few months. So the stable, what we consider a stable version of Grafana also changes frequently. So we can't we've got to have a process for like deciding what is the current stable version of Grafana. It can't just be a static thing. And so what we do is that we've actually divided the huge number of Kubernetes deployments we have into groups of plan and release type. Like I've just like labeled here as type. So there are some, for example, like free instances, that have the free plan, and they have the release type alpha. And there are some that have the release type beta and stable. And for each of these pairs, we assign them a version. So there is a version that's like considered like alpha right now, one beta, and there's one that's stable. And what you will notice is the stable version is the oldest one, of course, which it makes sense. Version X was the oldest version. It's now like stable. And other versions, they're being used by other release types, by instances with other release types. And so what happens is that like when a new version is released, we first introduce them to like the plan and release type that is considered the least stable. And we release this version to those instances, like run some tests, like wait a while, and if it feels like this is a good enough version, then we slowly like promote it to the next release type, right? So slowly Z will actually become, come to release type beta here, and then eventually it will replace X as the stable version. And usually, there's always a new version. We try to release like much more frequently to Grafana Cloud than we do, than the open source releases. So there are many more releases to Grafana Cloud than there are necessarily to the open source version. There's kind of another way that this picture could be more accurate. So this is a picture that we just saw for a few moments ago, unfortunately with a slightly wrong versioning, numbering. But this is pretty much, in this picture, it looks like there is one instance that we're updating, but of course that's not true. What a more accurate picture would be this, that at any time there's like lots and lots of Kubernetes deployments, Grafana instances running on Kubernetes, and they have different versions that need to be updated, and they need to kind of like over time be kept up to date. So what happens is that like, a developer will decide, essentially like what should be the stable version now, what should be the alpha or beta version. And over time, they will like update that in Git. And then, like different versions will start to be picked up by the Go application here. And of course, when you have so many instances, like failures can happen all the time, right? So it might be that you make a request and it doesn't succeed. There is like maybe some problem with the cluster, and the instance wasn't available, but may eventually become available. There's also the factor that we also have to update existing instances. So it's not just the new instances that get the latest Grafana version, but as a Grafana version gets to be considered more stable, we update existing instances to get like a more stable version. And so this actually becomes like sort of a reconciliation loop. So I hope this is not too much of a jump here. But this Go app isn't necessarily one app, but it's actually multiple systems. And the way they look like is very much like Kubernetes. So there is an API server which accepts requests for new instances from the user. There is a controller that regularly reconciles, compares the version mapping that we have in the API server versus the one that's like stored in Git. So it may be that a new version has been released and the manifests have been updated in Git. We've also got a controller for updating Grafana instances and creating new Grafana instances, because this is an eventually like consistent operation. So controllers kind of like work pretty well here. And suppose, for whatever reason, an operation fails, we just like try again after a few minutes. So that's how kind of like we continuously deliver, like new versions to these like hundreds of thousands of Grafana instances, because there's like always a loop. And in truth, like we've got many regions. So, there's like actually many versions of this picture, for example, the region in the US, like in Europe, like now we also have like Australia region. So, in essence, like this picture can look even more complicated. I think this is pretty much what I have for today. These are like some of the open source technologies like that were mentioned. I forgot to like add a picture of Git here. I also want to give like an honorable mention to Kafka, which is an open source technology that we're starting to use like a lot of at Grafana Labs. none of this kind of would really be possible. We couldn't really achieve this scale without Kafka, but I didn't really get a chance. I didn't really have time today to kind of talk more about it. But please feel free to ask me questions of how we're using Kafka. I just wanted to mention it, that's also an important system here. Thank you so much for listening and for being here. I'm very happy to answer any questions you might have. Thank you.
All right. Moz, can you hear me?
Yes, I can hear you.
All right. So thank you so much for this informative session, and it was also insightful. So,
Thank you.
guys, if you have any questions or you would like to seek further clarification on this topic, so please don't hesitate to share in the chat box, and Moz will be there to answer your queries as well. Okay, Moz. So let's wait for the questions so that you can answer them.
Yeah, sounds good. One thing a slide that I didn't really get a chance to add, but that's important, is that if you like working with these technologies, and just Kubernetes itself and stretching Kubernetes to its limits, we're also hiring at Grafana Labs, and so you can just go to grafana.com and kind of look at open positions there, or reach out to me on LinkedIn if there's something you're interested in. We're always hiring, so that's also something to mention. If you feel like there's a question that feels kind of off topic, please feel free to ask, and we can just see. Anything that comes to mind, it's okay. It can also be unrelated to my talk.
If you have any questions, please drop down. Moaz, I think there are no further questions. So thank
Sounds
you
good.
so much for this enlightening session. And your expertise and passion were evident, and your insights will be valuable in our endeavors. And we appreciate your time and efforts, and we're looking forward to future learnings from you, inshallah.
Of course. Thank you very much. And please feel free to find me on LinkedIn if you want to get in touch. If you think of questions later, always happy to answer them. Thank you.
Thank you so much. Allah Hafiz. Bye.